Today we're going to be looking at kinetic energy. So we know that energy comes in many forms. For example, heat or thermal energy, as it's otherwise known, light, nuclear, chemical. The energy stored in food is in the form of chemical energy, and potential energy, or stored. And we're going to be looking at potential energy a little bit today, but also in our next lesson as well. Potential energy is also the energy that you would have stored in a spring before it's released, or from a ball at the top of a hill. Now, energy can be transferred. Energy can be transferred from one form to another. For example, the electrical energy in a circuit can be transferred into light and heat in a light bulb, for example. We're going to be looking at how energy can be transferred to create motion. Now, energy is another scalar quantity. But it can be positive or negative. But it has no direction. In mechanics, we're only interested in mechanical energy. And this can take two forms. It's either kinetic or potential. So our kinetic is the energy of motion, and potential is, for example, a ball at the top of a hill before it's released. Now, if we have a body of mass m kilograms with speed v meters per second, the kinetic energy is going to be given by half times the mass times v squared. And kinetic energy is, well, if you think about it, you've got the kilograms from the mass times meters per second squared, and this is also the same as Newton meters, which is the same as joules. All forms of energy are measured in joules. But it's just these kind of be exercises in exploring the units of an equation are actually quite useful, can give us a deeper understanding into the physical nature, but also the maths behind the equation, and can help us understand the different principles. So it's always just a good wee exercise just to look at what units actually mean and where they come from. But when you're answering questions, always put the units as joules for any form of energy. So let's look at a couple of examples. Find the kinetic energy of a body of mass 3 kilograms moving at 5 meters per second. So half times 3 times 5 squared is going to give us 37.5 joules. A ball of mass 50 grams hits the ground with speed 10 meters per second and rebounds with speed 6 meters per second. Find the loss in kinetic energy that occurs. Now, just a wee side note, energy is never actually lost. It's changed and transferred to other forms. So when you lose kinetic energy, some of that energy that was kinetic energy is going to be changed into something else, whether it be sound or heat, but the overall energy in that system will not be lost, but it will be changed. So we're looking at the change that occurs in the kinetic energy, because some of the kinetic energy is going to be transferred into something else. So first, let's look at the mass. That's 50 grams. We need it in kilograms, so that's going to be 0.05 kilograms. So the change in kinetic energy is going to be the final kinetic energy minus the initial. So the final kinetic energy is half 0.05 times the final speed is 6 squared minus a half times the mass is the same, the initial speed, which is 10 squared. And this will give us minus 1.6 joules. So the loss is in kinetic energy is 1.6 joule. So remember in this that the although the velocity changes direction, kinetic energy is a scalar, so we don't need to worry about the direction of the velocity in this. So 1.6 joules of energy are lost. Quick little note, you sometimes people will subtract the velocity, so they would do 6 minus 10 and get minus 4, and then plug that into half mv squared with the minus 4. Don't do that. That will give you the wrong result. You have to work out the energy at each stage. So I hope that helps.